welcome back again. Welcome everybody once again. I cannot wait any longer for those who are yet to join us in the conference. I'll just go ahead and get started and probably maybe share the lecture recording with them. In case somebody join us in the middle, I will share again the lecture recording for our lab today. By now, you should have covered in the lecture the concept of enthalpy of reaction. Enthalpy of reaction is basically enthalpy of reaction, all right, is basically uh, heat. This is H here. I mean to say heat of reaction, heat of reaction. Some reaction when they take place, they either give away heat or they absorb heat for exothermic and endothermic reaction. This will be the reaction can either be endothermic, that means heat will be given off, or uh, exo thermic what? Exothermic reaction. You know the definition of those two terms, exothermic and endothermic reaction. What I want you to do is have a piece of paper. Uh, I will be going through the data sheet with respect to the heat of neutralization. I want you to just pay attention, take notes. What I'll recommend is read the background as well. Do not just rely on what I'll go through, along with the PowerPoint slide posted on module 10 for this lab. The objective for this experiment is to determine the heat of formation of a solution, all right? When potassium nitrate is dissolved to form a solution, either heat is given off or either heat is absorbed from the surrounding. We will also analyze data in the formation of a solution of sodium carbonate with H2O. H2O. How will we know that heat is given off or heat is absorbed? Is by taking note of change in temperature. We'll also look at the enthalpy of formation of complex tetraamine copper 2 sulfate complex. When it is formed, it can either be exothermic or endothermic. We will find out from the data collected for this. And then lastly is the enthalpy of neutralization, okay? Enthalpy of neutralization of sodium hydroxide and hydrochloric acid. By just looking at the, the PowerPoint slide, along with the data given on the PowerPoint slide, you will not be in a position to analyze the data. You still need to read the background. And I will highlight those sections in the lab manual. You need to go in there and get more information in order to analyze the data. Otherwise, don't think that, okay, I have the values on the PowerPoint slide. I'm just gonna, dive into the data sheet and proceed. No, you still need to read the background procedure in top hat. All right. We will, or generally chemists use what we call calorimeter, coffee cup calorimeter to study the heat of formation, heat of solution, or heat of neutralization. Using coffee cup calorimeter technique, we'll be able to study the heat given off or absorbed during these reactions. Okay. You saw in the quiz, all right. You saw on the quiz the diagram of a coffee cup calorimeter. It is given in the lab manual, all right, which is just a simple coffee cup. It is insulated in such a way that it is not lost or given up, right? It's not surrounded. There's an insulation. There's the thermometer here, which, listen, The thermometer tells you whether the temperature or whether the reaction is exothermic or endothermic. If the reaction is endothermic, the temperature will change. It is from 15 to 22. Temperature is rising up. That means the reaction is exothermic. If it is endothermic, absorbing heat from the surrounding, we expect the temperature to drop maybe from 25 to 18, depending on initial and final temperature. So this is just a simple Covey curve calorimeter, okay? And the data collected, or you'll see in the PowerPoint slide, were collected using the Covey curve calorimeter. Covey curve calorimeter. Now, the equation used for, all right, equation used for determining the heat, all right, heat is given or determined if you know the mass, Q, which is the notation for heat, is given by the mass, all right, mass, and this is in grams, times what we call the specific, let me just abbreviate that, specific heat. And this one is given in either joules per gram times degree Celsius, or sometimes this can be calories per gram times what? Degrees Celsius. And then times what? Times a specific or change in temperature. That means change in temperature. This means change in temperature is obtained from T final minus T what? T initial, where you're starting when the temperature changes. So this is heat of reaction. When we do it, we use this equation to calculate the amount of heat given off or absorbed, heat change in a reaction. If we know the mass of the solution, if we know the mass of a substance, its specific heat, the change in temperature, by using this equation, we can calculate the heat. We can calculate the heat. This is one equation. This is one equation for calculating the heat. The other equation is Q, all right, is given by C times change in temperature, where this is called the heat capacity, of what? Calorimeter. There are two equations we can use to find the heat of reaction. If you know the heat capacity of a calorimeter, you can just multiply by the change in temperature, Now, the data you will use, all right, let's see the data sheet. Just pull the data sheet and show you where the things will be. You will use here the heat capacity for calorimeter. 37.5, I'll allow you to use that value. We're not going to perform experiment for section 5.1. 37.5, and remember the units for calorimeter. Heat calorimeter, we will use 37.5. All right, C for calorimeter, take note of that, heat capacity, and then look at the subscript, 37.5, all right, joules, all right, we're gonna use joules for the calorimeter. We don't need to calculate that. I'm just gonna give you that. That's what you will use for the heat capacity for the calorimeter. Section 5.1, you don't need to do anything for that. And we will use that. It's on page 191. Somebody saying, where did I get that? I was looking for the heat capacity, page 191. Let me see, where am I getting that value? I can see the page is on top hat. I want to show you where I get that file. It is given section 5.1. This is 5. We haven't got there yet. I'm looking at 5.1. 5.1. We have to take the literature value. All right. Literature value for heat capacity. This is where I was looking for. So please fill in your data sheet, or if you are taking notes, write it somewhere so that you know you don't get stuck and say, where am I going to get this file? It wasn't given in the PowerPoint slide. If it is there, that's fine. And that is one case where I pointed earlier on that you need to read the procedure in order to do the calculation. And take note, it is joules per what? Joules per degrees Celsius. So our temperature will be in degrees Celsius, joules. Take note of that, all right? So that is the, for the data sheet. You need to fill in that here for 5.1. I'm just gonna walk you down the calculation.
Professor?
Yes.
So are the units for the heat capacity, is it joules or joules per degree Celsius, or like it said in the
joules per degree Celsius. Joules per
degree
Celsius. I just
awesome.
wrote that in my, let me just see if I can, right there. You see my slide? I just changed that.
Yes.
I know I had that, right? Yeah.
Okay, thank you.
So that is taken care of. 9.1, I mean 5.1. We have the literature value. It is given in the manual. Okay.
Excuse me?
Now, let's move on to section 5.2, and this is determination of the heat of formation of solution. All right. When a solution is formed by dissolving the two salts, all right, we have two salts right here, potassium nitrate and sodium carbonate. Salt 1, salt 2. This is salt 1, all right? Now, the specific heat, there is a reason why you are given this specific heat. Well, somebody will say that, you know, why am I given in Kelvin? And you'll get confused that should I change the degree Celsius to Kelvin and then plug it in the equation? Don't worry about that. Just cross out the Kelvin and change to degrees Celsius, because change in one, it's just about change in temperature. Let me give you a scenario. If the temperature is changing from 14 degrees Celsius to 15 degrees Celsius, that is 1 degree Celsius change. So if it is changing from 274 to 275, it's still the same. So don't get the units confusion. It's just work with joules per grams times degrees Celsius, and you will be fine for both salt 1 and salt 2. Now, mass of the empty container, mass of the, you know, calorimeter plus water, okay? This will give you the mass of H2O, all right? And you need to account for the mass of, you know, the ionic salt used. You may want to refer to the, all right, the PowerPoint slide, and then we see, all right, we see what is the mass of the salt 1. Look at this. For salt number 1, this is the specific heat. You are given the molar mass. This is the salt 2. You are given the specific heat. You already have it here. And the molar mass of each one of them. Now, you need to find the mass of, all right, the mass of You need to know the mass of the calorimeter. So if I know the mass of the salt used right here, molar mass. This is the specific heat to get the number of moles. All right, moles of the salt number one. It's the mass of what? Mass of H2O use of molar mass, mass of H2O use. We need to find the mass. Let's see where we get the mass of that. Hold on. I'm looking for the mass. Mass should be given. Let's see, mass. Right here is the data on slide number 12. Slide number 12 in the PowerPoint slide, we have the information to complete the data right here. Let's just minimize this a little bit so that we see or I can minimize this. Mass of H2O is 50 grams. This is the mass of H2O we have. So mass of H2O and mass of ionic salt. So you're gonna take note of the temperature change, mass of hot water. You will increase using this equation. All right. Q for the calorimeter. If we know the mass of the calorimeter, and I mean the heat given mass times the specific heat times the change in temperature. So for salt number one, this is the specific heat. Mass of the solution, all right, mass of the solution you will account for. We need to have the mass of what? Mass of the salt, right? Let's see if the mass of H2O. We know the mass of salt number one, salt number two, mass of water, mass of some information are missing. We should have the mass of each one of them there. Let's see. Yeah, there should be mass of H2O, mass of the final. So in case of this, let's see. I need to find the mass of each for the solution, mass of H2O, mass of the salt. We will find the number of moles of what? Number of moles of the salt by dividing it by its molar mass. So for line number 2 here, number of moles. So this is 2. Number of moles is given by the mass of molar mass. I need to get you the mass of, I need to get you the mass of the ionic salt. This is what I am showing you here in terms of I want to share right here. This is the mass of line 2 on the data sheet. You'll have to take the mass of the ionic salt all over the molar mass over molar mass. That will give you the number of moles, number of moles of the ionic salt. Okay. Now, uh, once you find the number of moles for line 2, mass of the solution. So we need to get the mass of H2O and mass of the salt so that we use the equation. So you can add the mass of the salt and H2O for line 3. This is pretty straightforward. You're gonna do the same thing for that. And then look for the final and initial temperature to get the change in temperature. So for here, you will have to find you have to find the line 4, you have to find the change in temperature. This is T final minus T initial, which means final minus initial. Whoever shared this PowerPoint slide, I'm gonna share it again with the information for mass of H2O, mass of the salt 1, salt 2, in order to plug in the information. This is for line 4. Change in temperature is T final minus T initial. You need to take note of the initial and final. So this is line 4. For line 5, see line 5, Q for the calorimeter. We're gonna see for line 5 here. All right. For line 5, Q for the calorimeter. Remember the equation. This is for the calorimeter. Q for the calorimeter is given by line 5 is Q for the calorimeter. Cal is given by the heat capacity for the calorimeter times line what? Line 4. Because we know line 4 is change in temperature. Change in temperature. All right. And the units should be in joules. Remember, this was given in 5.1. In 5.1, we know the literature value for the heat capacity for calorimeter 0.5 joules per degree Celsius times line 4 change in temperature, of course, is change in temperature is in degrees Celsius and Celsius will go away. You remain with joules. This should be in joules, all right? Should be in joules. That's line number 5. I'm circling it and saying that this is line what? Line 5. Somebody had posted a question before. My Zoom chat window was down. I think Maya Cruz had a question. Use Celsius to really work it out. Thank you. Somebody had answered that. So moving on to, all right, line 6. We know the calorimeter. Q for the solution. Just gonna minimize this. Q for the solution is given by, for line 6 here, Q for the solution, that is for solution, is given by the mass of the solution. And remember, this is H2O plus the salt. You have to find the mass of the solution times the specific heat of what? Specific heat of our solution times change in temperature. Change in temperature, this is degrees Celsius. So it's going to be H2O. This will depend on, right here, for line 6, look for salt. This is a function of salt number 1 and salt what? Salt number 2. Number 2. So specific heat is a function of which salt are you dealing with. Let me just bring back the data sheet. If you look at line 6, we are going across. This is salt number 1. What is the specific heat? It is given at the top right here. You see, this is the specific heat, and I say that please just ignore the Kelvin. Let's use degrees Celsius because we are given the change in temperature in degrees Celsius. So specific heat for salt number 2 is given here as well, so that when you use the Q4 solution here, you will understand which specific heat I'm going to use for solution 1, for solution 2. So here is the equation for line 6. The heat of solution, mass of the solution, which is a function of mass of H2O, and salt, or mass of the salt. I'll give you the mass of this. It seems like the instructor who prepared this didn't give us, but I'll send you more information, more values. I don't have the data right now, but apparently they didn't include the slide on the data. I'll find out and share with you the mass of H2O and the mass of the salt. Specific heat, you got to look at which salt are you dealing with. Is it salt number 1, salt number 2? Use the specific heat for each salt. Change in temperature is going to be final minus initial. You will be given that, and you plug in the equation, for line 6. Now, line 7, you got to be pay attention to line 7. Q for the reaction, it's pay attention to the subscript. When I say Q for the reaction, QRN, look at my, how are we going to find the equation for that? It is not, listen, it is not mass times a specific heat, There's an equation in the data sheet we need to rearrange. And again, this is number 7. This is line 7. That is line 7. There is an equation in, it's also in the PowerPoint slide if you want to. Right here, you see the Q for the reaction. It is given by the negative Q for the solution minus the Q for the calorimeter, which you already have these values. You already have those values, and it should be in joules. Should be in joules. Pay attention to this. All right. You will look at the Q for the reaction. If I know the Q for the solution, Q for calorimeter, which you already have those values. I don't know which line it is. I think it is line 6 and line 5, 6 and 5. So if I do that, this is the value for line 6, all right? And this is line 5. This is line 6 and line 5. Line 6 and line 5. for solution and calorimeter to get line 7 here. Now, for line 8, enthalpy, this means change in enthalpy. Delta H, this means change in enthalpy. Enthalpy, right? Need to minimize that. Change in enthalpy. So reaction, it is, you need to divide, all right, line 7, if you're dealing with the mass of the soul. So whatever you will be given for the mass of the soul, this will be line 7. This is 8. How do you get 8? It is line 7, all right, of mass of the soul, over the mass of the soul. This is how you determine the value for line 8. Line 8 is basically the value you'll get for line 7 divided by the mass of the soul. Again, I'll give you the data, the information, the mass of the soul for soul number 1, for soul number 2. The only difference between 9 and 8 is in line 9, you will change or you will divide by the moles of what? Of each respective soul. So if I know the number of moles from line 2 for each soul, so it's going to be line 2, all right? It's going to be line 7. So if I have here 9, this will be line 7 over line 2. That is what I'll do for item number 9 or line row number 9, you may want to call it. The value you will get for line 7 divided by line 2, that might make more sense because, you know, when it is in this form, you may wonder, how do I get this? It is the Q of reaction, which is line 7, all over the moles of the soul, which is line 2 here. By this time, you should have, all right, you should have the value for line 7 and value for line 2. Remember, units is in joules per mole, joules per mole. Any question for part or section 5.2? Any question for 5.2?
Yes, when are you going to give us the values?
I'll try to find out from the coordinators for camp by end of the day, not later than tomorrow. I don't want to get into the weekend because I know, you know, we have a lot going on, and I try to give you 1 week in advance to work because you can think. As soon as I'm done with this, I'll send out the information, the values, the measurement, the data. Probably they missed to put in there, but I'll share with you by end of the day.
Will it be on Canvas?
Yes, it will be on Canvas, and I'll send you an email once I make them available. Just like the way I send out the announcement. If you are program your phone to receive alerts from me or from Canvas, you will see that, you know, an announcement is there through Canvas. I'll let you know.
Thank you.
All right, thank you. So that is one thing missing, but I'll just try to walk you through how you will proceed with the data analysis. Any other question on 5.1 or no, I mean 5.2? Before we get to 5.3, if there is no question, I don't want you to lose points again on 5.3 because at the top here, look, write the balanced equation. You can't just write the balanced equation of your head without reading the background. You need to read the background procedure on top of it to see the reaction between amine and copper 2 sulfate to form a complex. And you are expected to have covered the stoichiometry. I know maybe you forget about it and you thought it was just, you know, it was over. I did the quiz, I did the exam. No, you'll have to apply the concept of stoichiometry in 5.3. Let's just go real quick to 5.3 and I'll walk you through what's all about. Let's look at the reaction between between copper. All right. What we are talking about is copper 2. I need to see the equation where we have copper 2 right here. Look at this. This is where you are expected to come and read, all right, experimental overview 3.0, copper 2 sulfate. This is called copper 2 sulfate and what? And ammonia. It could be ammonium hydroxide, all right. And this is reaction 2. Reaction 1, reaction 2. And you need to, okay, you need to write the balanced equation. What is the balanced equation? What's the mole ratio between? What is the mole ratio between? Forget about, forget about equation 2a here. I want you to see the formation of a complex here. It's just the equation. It's the same thing, net ionic equation. This is how the complex is formed. What is the mole ratio between copper 2 sulfate and ammonia? No
Is it 1 to 4?
1 to 4, thank you. Oh, Alvaro, I think maybe you are responding to my earlier own question. That move on to 5.3. Thank you, I got you. So thank you. It is 1 to 4. The reason why I'm just highlighting this is you will calculate the limiting reagent and you know how to proceed with the limiting reagent concept. It was lab number 5, okay? Forget about the product side, the reactant side. So I want you to pay attention that by looking at this section, you should be able to write the balanced equation. You should be able to write the balanced equation. And read this section here. In order to understand, let me ask you this. Is this copper or copper ion? Or rather, is this copper or copper 2 ion? There is copper 1 ion, there is copper 2 ion, and then there is copper. Which one am I? The one highlighted on the screen. Which one is that? Is it copper 1 ion, or copper 2 ion? Somebody
Is it
talk
the
to me.
copper 2 ion?
Copper 2 ion, thank you. So why I'm bringing this also, you are expected to have really, understand why we are given, why you being given the net ionic equation. You will see why. Let me just bring my, data sheet right here. And we will start off with by identifying the metal cation. Quite often when when we do this on face-to-face, student fail to identify what I'm looking for. When they say metal cation, and then when they say complexing reagent, by that you should know what we are looking for here. I don't want to do that. We just went through the net ionic equation, read that section in order to know which one is which. I don't want you to give me, when we say cation, what is cation? What is anion? I know you covered that before. And then once you identify that, you may not know what is a complexing agent or reactant, but once you identify the other one in the reaction, then the other one will be something remaining. If you only have 2 reagents and you are able to identify one, and then of course the other one will be what I'm looking for. So you need to identify those guys right here. Now, molarity here, all right, you should be given the molarity. I think it is in the, you should have been given in the background. I believe we have the reagents. If not, I'll also find the information for that so that you identify. You don't need to guess. I think there is somewhere given for molarity. You need to be given molarity for this. I'll also make sure you get the molarity, the concentration. Let me see if I have it in the PowerPoint slide. I don't know if this is, we should be given the molarity for copper 2 sulfate. All right, we need to have the molarity of each one of them. All right, molarity of each one of them. And in case, let me even give you that. I think I have here my molarity. Please write that. Okay. Unless things change, I know. I'm just looking at unless it is labeled in the lab, I'll provide that as well. We should have the molarity of copper 2 sulfate. Molarity of copper 2 sulfate. We need to have that. I'll also give you that so that you determine this. We need to have the molarity of this and molarity for that. And with that, it should help you using the equation, you know, with the molarity here and the molarity here. The volume for the complexing agent as well as the cation. You need to read the background here. Let's see. I think we should have that for the complexing agent. You need to come down here and read so that you know which volume or what is the volume you need to put in there. The complexing agent, let me show you what the directions say. How much of each solution, each reagent do you need to measure out? All right. Calibration, we did that. Solution is right here. The only thing we are missing is the molarity. You will be given that. If it was like in the lab, then I'll have it labeled on the container. You just read what is the molarity you plug in there. So unless you come here and see, all right, read, measure. Look at what is highlighted. Measure out 25 ml of aqueous ammonia. All right. Look at this. Measure out 25 ml of copper 2 sulfate solution. You will need that information so that you feel. If you don't come here and read, it's gonna be difficult to fill the information here. So you need to write the volume here, volume. And for line 10, all right, section 5.3, let me just share that 5.3, 5.3, line 10 or 10, number of moles is given by molarity, which you know, molarity times volume in liters. Volume in liters. Please write volume in liters. I'm using subscript L for volume in liters. So once I know the volume, I just showed you how much of it you need to measure out. Change that to what? To volume in liters, because we know molarity. We are using this. Molarity equals to number of moles like that over volume in what? Volume in liters. Volume in liters. I'm rearranging to get the number of moles right here. This one will give you the volume. I need to give you the initial volume before you mix the solution. Before you mix the solution. All right. So you need to find out the number of moles. Once I give you the molarity and you know the volume from the background, you should be able to find the number of moles for line 10. Likewise, for the temperature, I'll give you that. You find the average, all right, the two, and then find the average for the volume. You'll come down here and do what? and proceed with the change in temperature. So you'll see the final temperature and the average. Final minus initial, which is the average, will give you change in temperature. Now, mass of the solution here, all right, mass of the solution is given by density times the volume. Look at what I'm highlighting here, reaction mixture. Remember, you had to, when you say a mixture, it's not a pure substance. That means you took substance A, you took substance B, and then you put them together, you end up with a mixture. Reagent A, reagent B, you put them together, you end up with a mixture. What is the total volume? It's not, it's not one reagent. I've seen quite a number of reports coming through where somebody is using the volume of one reagent. Nope. Don't get stuck with 25 ml you measure out, or 25 ml stated in the procedure. No, it is the reaction mixture. Once you put them together, what is the total volume? That's what you need to use right here in line 13. So if I'm doing 13, this will be density, and you have the density, all right? It is given right there, times, let's say, total what? Total volume, which is 25 plus 25. You are given in there. I'm doing there is number 13 there, 25 plus 25. And you have the density. You have the density. You are given the density of the reaction mixture here. That will give you the mass. And then you move from, use the same equation we used before in finding or determining the calorimeter here. If you look at the line 14, the heat of calorimeter use this equation. Q for calorimeter is the heat capacity, all right? Number 14, Q for the calorimeter, given by the capacity calorimeter times line what? Line 12, line 12. And this is from 5.1, that's 7.5 joules. What I'm writing down here is this. This is what I'm doing here. For line 14, the heat capacity for calorimeter, section 5.1, you have the literature value. Line 12 is the change in temperature. This is line 12, change in temperature. That will give you. Then line 15, 15 here, all right, it is the Q, it's the mass times the specific heat times change in temperature. Again, you need to, this is, let's just see the equation here. For this part right here, you are not given, just like in section 5.2, you are given the specific heat of salt number 1, specific heat of salt number 2. But change in temperature, you have this. Mass of the solution, you have that. But where is the specific heat? Unless you read the background to get that information, all right, you will not be in a position to understand what is going on. Let's go to overview 3.0. Overview 3.0. Overview 3.0, I think overview 3.0 here. If you go down somewhere, let's see, right here, not overview. Below equation 16, equation 16, look at what I'm highlighting, what is given right here. You can read on your own, all right? Assume the resulting complex, we are forming the complex, as a density of 1.10, this is what we need, and the volume of 50.00, that is, that's the information I just gave you, 50 plus 50, I mean 25 plus 25 is 50. And the specific heat, I want you to really see this, and the specific heat. If you don't read here, you'll be like, I need that. So I'm just helping you out to figure it out what you will use. So 4.18 degrees Celsius. So here, this is 4.18 joules per grams times degrees Celsius. And of course, the rest will be straightforward. I just wanted to tell you that, without that value, you wouldn't be in a position to do what? To complete equation number 16, right here, 15, sorry, Q4 solution. The rest will be pretty straightforward, all right? The rest will be straightforward in the sense that Q4, the reaction, you rearrange this equation on, all right, you rearrange this equation on the PowerPoint slide. This is the equation you need to rearrange for line 16. Q for the reaction equals to the Q for the solution, which you already know for the solution. This is for the solution, by the way, minus Q for the calorimeter. We already know the heat of calorimeter when we have that. And of course, the limiting reagent, that's why I had to point out why we paying attention to the stoichiometry. You know how to find the limiting reagent. If the mole ratio was, all right, if the mole ratio was 1 to 4, you say, or you take, if copper sulfate is the limiting reagent, how much of the product will be produced? Write down that, maybe in terms of moles. And then you say, if ammonia is the limiting reagent, how much of what? The product are you expecting to get? Whichever give you less amount of the desired product, which is copper 2 tetramine complex, is your limiting reagent. And then of course you should be able to figure it out what? The number of moles of the metal complex from what? From the limiting reactant. From the limiting reactant. Using the stoichiometry in the balanced equation. Like I said, you will get the mass or the concentration of each species. And then line 19, of course, is given by the Q for the reaction, which is line what? Line 16. For line 19, enthalpy of reaction, change in enthalpy of reaction is Q for the reaction divided by the number of moles of the metal complex form, which is line 18. Line 16 over line 18 gives you line 19. So if I may write that, this is given by line 16 over line 18. You have to use the subscript to figure it out what you are looking for. For step number 19 or item number 19 is line 16 over line 18, and that will take care of section 5.3. section 5.3. Any question on section 5.3?
I have one question.
Yes.
So for the balanced equation on the PowerPoint, there are two equations. One of them looks more like a complete and one of them is more of a net, I think you said. So which one do we use? The top
Either
one
both
or the
of
bottom
them,
one?
I'll give you credit for both of them. Either way, the mole ratio is the same. That's the point.
Okay.
So if you write equation 2, as you see on the screen, make sure it is net ionic equation. If you write the molecular equation, make sure you write it correctly. In other words, you cannot have this and then have this, you know. So both
Okay.
of them will work.
Okay, thank you.
All right. Any other question? All right, if there's no question, real quick, section 5.4, heat of neutralization. Neutralization basically is just one of the types of reaction we have been covering all along. When an acid reacts with a base, what takes place is basically neutralization. So here, we will also work with an acid, and you will have the concentration. You will have the concentration, all right, of each acid. You'll have the concentration of each acid. All right. And again, take note of the density of solution, so that when you mix this and that, all right, what is the density? You're going to use that to determine the volume. And then we will assume the specific heat of solution as above, all right? That means the specific heat will be 4.18, just as we assumed before when we will be doing the calculation. So you need to pay attention to what assumption here. This is the density of the solution, and the specific heat is the same as we assumed before. That is 4.18. And now, with that, you got to read the direction, how much of what is required. Look at the step number 22. Measure out 25 ml of sodium hydroxide. You will be given the concentration so that you take note of what? You take note of molarity, take note of molarity, and then you calculate the number of moles. So once I give you the molarity, you will be able to find the number of moles. What I want you to pay attention is the amount of each reagent. So the first, 25 ml of sodium hydroxide. And then look at step number 24, measure out hydrochloric acid. So you've got to come back here and take note of that as well. With that, it will be much easier for us to move forward. Of course, everybody knows the balanced equation between what? HCl, read the background. Balanced equation between HCl and NaOH, hydrochloric acid and sodium hydroxide. You'll be given what? Identify the acid. What is the acid? Read the background. Molarity, you'll be given that. Volume, we just went through that. Number of moles, all right. Number 20 here, you will use the molarity equation. Number of moles will be given by molarity times volume in liters. Remember, this is not the total volume. It is just the volume of the acid. When they say moles of acid, it means it is talking about the acid. So here is the equation. Number of moles is given by the molarity times the volume in liters of the acid given in there. You'll be given the molarity. Identify the base, you know that. You'll be given also the molarity of the base, and then it's with the same thing. The information here, you'll be given initial temperature, initial temperature for each one of them, average temperature, and then the final temperature. Change minus change in temperature will be final minus the average. Final temperature of the product minus the average once you mix will give you the change in temperature. And of course, based on what we look in the background, you know the density of what? Density of the solution. Just like before, volume of the mixture. How much of HCl did you measure out? How much volume of NaOH did you measure out? When you mix them together, you end up with a mixture. When you put them together in a container, you end up with a mixture. And the volume we are using here is the reaction mixture, not individual volume. No, it's the total volume, which is 25 plus 25. Now, the equation for question 25, line 25, it's still the same thing as calorimeter, except let me just write here 25. The Q for the calorimeter is given by the heat capacity for the calorimeter times the change in temperature. This is line what? Line 23. Line 23, and this was all the way from 5.1 joules per degree Celsius. Let me minimize my screen here, and C25. Line 25 is the heat of calorimeter, which is given by the heat capacity of the calorimeter times the change in temperature. Change in temperature for this section is line 23 given. I'm using this equation on the PowerPoint slide. The heat capacity of the calorimeter times the change in temperature. That's what I'm doing here. And then, of course, the subsequent equation is the same as the previous section, okay? In the sense that you will have to find the mass of the solution. You already know the mass of the solution in line 24 times the specific heat for line 26. All right, 26. This is what we will do. Q is given by the mass in grams times the specific heat times change in temperature. You already know change in temperature. We were told to assume that it is 1.8 joules per gram times degree Celsius. This is what I was doing on line 26. Q for the solution. I need to put it abbreviation for solution. All right, not reaction. It's the mass of the solution times the specific heat of solution. We are told to assume it is 4.18 times the change in temperature. You already know the change in temperature. You already know the mass of the solution. And then from there, you just plug it in and get the item for line 26. Line 26, all right, that is what you need for line 26 here for the solution. And then for reaction, all right, for the reaction, you'll have to rearrange the equation. Negative Q2 for the solution, negative Q for what? For the reaction to give you the heat of reaction. And then, of course, the rest will be straightforward, okay? You'll have to find from the balanced equation, and the number of moles of each reagent, that you'll determine either one, you can use either one of the product, could be sodium chloride or H2O, whichever way you want to use as your reference to determine the number of moles. For example, write a balanced equation between, sodium hydroxide and HCl. If this is the number of moles of HCl, how many moles of sodium chloride will be produced? If this is the number of moles of sodium hydroxide, how many moles of sodium chloride will be produced? The one which gives you less amount of moles, all right, will be limiting reagent, limiting reagent. Line 29, the number of moles of H2O produced, use the stoichiometry from the balanced equation. From the balanced equation, you should be able to figure it out, the moles of H2O produced. And lastly, the change in enthalpy of reaction is the Q for the reaction, line 27, all over the moles of H2O produced, which is line 29, line 29. Hope you are taking notes. I will share the data by end of the day or tomorrow. I'll let you know. Other than that, if there is no question, this marks the end of our pre-lab session. Is there any question before I end up the Zoom session? Any question? Any question? If there is no question, I will end up the session. We'll meet again next week, same time. Please, I'll share the data again by end of the day or tomorrow. The class is dismissed. We'll meet again next week. Thank you.